Today, we're diving into a material you've probably never heard of, but it's absolutely vital for national security and some of our most advanced tech. We're talking about boron carbide, or as some call it, black diamond.
So, what would happen if the supply chains for the world's toughest, most advanced materials just snapped? I'm talking about the stuff used to build fighter jets, nuclear reactors, you name it. And listen, this isn't some far-off what-if scenario. It's happening right now, and believe me, governments and entire industries are scrambling.
At the heart of all this is what you could call the super material squeeze. See, all our modern tech, it's completely reliant on a small group of materials with these insane extreme properties. The catch? The supply lines for these materials are super fragile, and they're all concentrated in just a handful of spots on the globe.
And just look at the scale of this concentration. It's kind of nuts. For 19 out of the 20 most strategic minerals, one single country, China, controls around 70% of the entire global refining capacity. That's not just a small advantage, it's a massive strategic vulnerability for basically everyone else, from defense contractors all the way to big tech.
And yeah, that vulnerability, it's being put to the test. With all the trade tensions heating up and recent export controls on these super hard materials, what used to be a theoretical risk is now a very real, very present danger. Because think about it, when your main supplier can just decide to turn off the tap, you've got to find alternatives, and you've got to find them fast.
So, what's the alternative? Well, that brings us to the real star of the show today, a material that's stepping right into that strategic spotlight. You might know it as black diamond.
Okay, so its formal name is Boron Carbide, or B4C if you're looking at the chemical formula. At its core, it's an advanced ceramic, basically a man-made compound of boron and carbon. And its claim to fame? It really boils down to two things. It's ridiculously hard and, at the same time, surprisingly light.
That nickname, Black Diamond, really nails it, doesn't it? In the high-stakes world of material science, this stuff isn't just another ceramic. Its performance is so off the charts that it's truly in a league of its own.
So just how hard are we talking? Well, on the Mohs scale, where a diamond is a perfect 10, boron carbide comes in at a seriously impressive 9.3 to 9.5. Think about that. It's one of the hardest materials humans have ever created. Only diamond and something called cubic boron nitride are tougher. And, importantly, it's way harder than the old industrial standby, tungsten carbide.
Okay, so with specs like that, you can probably guess this isn't something you'll find in your kitchen drawer. Nope. Boron carbide is a material built for the most extreme jobs out there, the kind of places where failure is just not an option.
This really shows you where all the demand is. The biggest piece of the pie, 35%, that's all defense and armor. Right behind that, you've got nuclear energy taking up a quarter of it, and then high-end industrial parts at 20%. I mean, these aren't just random markets. We're talking about the very pillars of national security and industrial power.
So what's its number one job in defense? It's pretty simple: stopping bullets. Boron carbide gets pressed into these lightweight ceramic plates that go into body armor and vehicles. And when a projectile slams into it, the super hard ceramic just shatters it, absorbing all that kinetic energy. You get unbelievable protection, but without all the weight that would normally bog down soldiers or vehicles.
Now, let's jump over to the nuclear world. Here, boron carbide is all about safety. It's what's known as a neutron sponge, which is a great way to put it. It basically soaks up neutrons without becoming radioactive itself. That makes it absolutely essential for the control rods inside nuclear reactors, giving operators the power to safely control that fission process.
And then there's industry, where its crazy wear resistance makes it a total powerhouse. Just think about things like sandblasting nozzles or those high-pressure water jet cutters that can literally slice through steel. I mean, those parts take an unbelievable beating. Boron carbide just outlasts pretty much everything else, which means less downtime and lower maintenance costs. It's a no-brainer.
So with that kind of performance, it's clear boron carbide isn't just filling some tiny niche. It's actively going after the big, established industrial materials. Which, of course, brings us to a head-to-head matchup I like to call the Carbide Showdown.
For ages, tungsten carbide has been the king, right? The go-to hard material for industrial tools. But here's the deal. Boron carbide is both harder and a whole lot lighter. Now that top-tier performance does come with a higher price tag up front. But for certain jobs, the advantages are just, well, they're too good to pass up.
And it's not just talk, we're actually seeing this shift happen. Take high-performance water jet cutting, for instance. Boron carbide nozzles last way longer and give you a more precise cut. Or think about heavy-duty mining equipment that's grinding through abrasive gunk 24/7. Its insane wear resistance completely justifies the switch. It's a classic case of a higher upfront cost leading to a much lower total cost over time. This all shift really points to an exciting future for advanced ceramics in general. But boron carbide's path to becoming a mainstream player, well, it's not all smooth sailing. There are some hurdles. Let's take a look at what's on the horizon.
Right, so there are three main challenges to tackle. First off, making it. The process uses extremely high temperatures, which guzzles energy and keeps the costs high. Second, like a lot of these super hard ceramics, it can be brittle. It has what we call low fractured toughness. And finally, and this is a bit ironic, isn't it? The supply chain for the raw boron ore you need to make it is also highly concentrated.
But even with those challenges, the confidence in this material's future is solid. Check out this number. The global market for boron carbide is expected to hit nearly $300 million by 2036. And that's not just some wild guess. It's based on some really powerful trends we're seeing across the board.
So why all the optimism? Well, you've got this kind of perfect storm of three major forces all coming together. First, that huge geopolitical push for secure, reliable supply chains. Second, you've got amazing advances in manufacturing, like 3D printing, which are letting us make complex parts that were just impossible before. And third, we're seeing brand new uses for it pop up in fields like advanced electronics and even energy storage.
And that really brings us full circle right back to that question we started with. As materials like boron carbide become more and more critical for defense, for energy, for our technology, securing a steady supply isn't just a business problem anymore. It's a national security issue. The quiet, strategic rise of this black diamond really makes you think, doesn't it? Maybe the next great global conflict won't be fought over land, but over the very materials we use to build our future.